My talk today is titled Sandbox Data Science, Culturally Responsive Pedagogies as a Path Toward Epistemic Agency and Inquiry-Driven Learning. It's a bit of a mouthful, and this sort of dense title, if you want, has been a long time sort of coming. All of you probably are familiar with theories on culturally responsive, or sometimes referred to as culturally relevant pedagogies, advanced by folks like Gloria Ladson-Billings and Geneva Gay, and everyone who's taken it up in STEM education and computing. And so this project is one where I noticed there wasn't a lot of effort to sort of support learners in developing their freedom, if you want, to enact STEM in ways that were personally, culturally, or sociopolitically relevant. And so we use this lens as a way to sort of describe that in a specific context. The context is data science, computational data science specifically. And so because no one had really been doing this work, I know a couple of scholars who'd been describing something called emancipatory data science that comes close. My team and I sort of just began to describe this as a sandbox data science approach, a space where learners could enact and do data science in ways that were, as I said earlier, personally meaningful. And so that's sort of the background behind this sort of dense title, and I hope that you can get where I'm coming from, and then maybe it inspires you to sort of think about your own scholarship in similar ways. And so before I begin, I just want to acknowledge, I mean, we're in a virtual environment technically, I guess, but I'm also still present here in El Paso. And I want to, using this slide, acknowledge the land that I'm on and the resources that sort of drive my work, and my ability to carry out this scholarship are grounded in environments that was occupied long before I arrived and long before UTEP was created. And so those are listed there. And we honor the history and cultures that these cultures and peoples brought before us, as I seek greater awareness of the myriad ways in which their legacy can guide partnerships and mutually fulfilling relationships ahead. And so to begin the talk, what I'd like to do is just give you, as any great teacher, I guess, would do, is give you a sense of where we're going. And so I'm going to start by introducing myself a little bit more and my research program, and then we'll dive into, in broad terms, what's happening in the field. Most of you are probably familiar with, and if not, it's data science, trends that are happening in the field, opportunities, and some tensions that sort of motivate this thread of my work. I'll give you a case example of a project that was funded by NSF soon after I started my work as a researcher and faculty member here at UTEP. It's called Coding Like a Data Miner. And then we'll look at some outcomes in that project, and then we'll, at the very end, hopefully reflect on principles for open inquiry learning design. Open inquiry being harkening back to this idea of sandbox data science, or epistemic agency, that is the freedom to conduct inquiry in a way that is sort of consistent with attributes of the learner and so on. And then we'll discuss and address any questions you might have. And so to begin, I'll introduce you to who I am and my research program. And so I, as Sadia pointed out, went to undergrad in South Florida, so not as far from you all back then. And I studied bio and English, but every time I got like a summer break, I would either do research or like in biological sciences, or I would teach. And I enjoyed teaching a whole lot. And so after I graduated, I became a teacher for a little while. And then I went to grad school to get an engineering degree because I felt like I had sort of reached a threshold. And then after, or a ceiling, if you want. And so then I went back to teaching and I felt that same feeling again. And so I applied to grad school at Penn GSC and I was admitted mostly because my advisor, I think mostly because my advisor was doing a project in biomaking and I had a big a sort of a background in biology. And so it made for a really good fit. And in exchange for my contributions in the biology and in that work, I learned a lot about computing. In fact, my advisor was a code developer of the block programming platform known as Scratch. And she was doing a lot of work in electronic textiles that's using conductive thread and programmable Arduinos that are circular. We call those lily pad Arduinos as an example, to make garments or clothing that could be programmed. The LEDs could be programmed in them, and we called this electronic textiles. And I would add a culturally responsive approach to computing. And so after I graduated, after being a postdoc for a year, I graduated and joined the faculty of UTEP in 2020. All of my work centers around these three bubbles here. I like to tell people that I study perspectives. That's what people think and know about learning. Participation, that is how they enact what they've learned, or in the process of learning. And places, that is how you design an environment, learning environment, to afford or constrain things or the myriad ways that the learning environment might do that. And so I made this alliteration, perspectives, participation, and places, as a way to um, sort of uh, represent all of that. And then these bubbles and their relative size represent sort of the focus of my research program. In fact, computer science was probably the biggest bubble because I had got a lot of funding from the NSF, as Sadia pointed out, to support that work. But recently, I was awarded a $1.7 million grant to carry out the synthetic biology work, which I'm glad to talk with you all about um, um, in another time. But as you can see in the bubbles there, I study everything from gaming, computer science in different ways, and synthetic biology. Today, we'll talk a little bit about the computer science work in the form of computational data science, which is an area that I took up as I started here at UTEP. In total, I think my work explores what I like to describe as moments of paradigm shift. And so the illustration at the very bottom sort of represents that for life sciences, wherein we lived in a world where inquiry was conducted through description, and then once, or induction, if you want, and then once we had requisite foundational knowledge to really understand the natural world, we started being able to replicate it following a set of steps. You could replicate everything from like an enzyme reaction to cell structures. And now we live in a different space where we can actually design with intention with the life science. Similar paradigm shifts have occurred in other fields, including with computing. As you can imagine, data science was probably a field where you collected evidence or data in very analog ways. And then when computing became sufficiently cost effective and accessible, people began to think about scaling it in ways that we had never seen before through efforts like data mining. And so now we have to think about, as an example of what I do in these spaces, how to best design, assess, and understand learning practice and environments that afford these kind of tools. And so I've been really productive as a result. I'm very fortunate to have a lot of collaborators being willing to get on this journey with me as an assistant professor. Right now, we're hiring before the bio grant, or we got an award to hire three postdocs over the course of 3 years. I think it's 3 years. It might be two. I have to double check what I wrote in the um, what we wrote in the job call. But if you know anyone that's looking, has a computing background and is looking for a postdoc with good support, good funding, and a lot of mentorship, please reach out or point them my way. These are some of the awards that we've gotten in the last 4 years. I've also had a really productive writing um, stint, if you want. Most of the works that I work on include lab members on my team. Whoops, lab members on my team that include postdocs and former doc students who are now faculty members elsewhere, and a number of undergrads and graduate students. Many of whom are listed here, and that come from different universities that collaborate or that are at Utah. So along the coding, like a data miner project, I just want to give you a little bit of background around some of the work that this team has produced recently. There's an organization called the International Society of the Learning Sciences. And recently, this past summer, actually, our team presented a few of these our insights from this work. And I'll dig into this a bit more when we move along. But the three papers I'll just share with you here that were led by some of my students include examining computational data science, which I'm going to dig in today with you all uh, in terms of learning outcomes. So studying what people learn as a result and what they think about data science and computational thinking as a result of that learning. That sort of connects with this whole idea that I study perspectives. We also presented a paper that year, this past summer, on computational data mining as a tool for exercising sociopolitical inquiry. So as you can imagine, teaching kids how to data mine or scrape Twitter for thousands and thousands of tweets and then analyze that as a way to explore, as I said earlier, personal interests, cultural histories, or maybe even a socio-political concern like whether or not there is gender parity when it comes to pay and what people are talking about on Twitter. And so this paper demonstrated for folks what this might look like in a class where computing meets math meets inquiry. And in the third presentation we had that year, we talked about, I guess if I drew from the alliteration I shared before, practices. And so in this paper, we, an undergrad, Andy Scarola, explored what it looks like to support or scaffold learners when you can imagine a classroom of 20 or 30 kids all doing their own sort of inquiry project or science project using computational data mining can be daunting. That could be daunting to a teacher who is used to just teaching one experiment or one inquiry project that everyone follows. And so in this very epistemic sort of agentic spirit, we explore what it might look like to support that kind of engagement. And so what Andy did here was explore scaffolding techniques that involve peers giving each other critique and feedback so that they can develop their projects better. She followed the turns of students when they were really productive and in ways that we might replicate that at scale. So this is sort of a little bit of a background related to the type of research I do in sandbox data science or computational data mining, or if you want, coding like a data miner. But let me zoom out a little bit to share with you what I observed as trends, opportunities, and tensions in these areas. And so years ago, when I was a doc student, and then early on as a first and second year assistant professor, I had carried out what I describe as side projects. So I don't know if all of you are doctoral students or what your sort of background is professionally, but if you can imagine being a grad student and doing like your classes and then research with your advisor and then carving out space to get with your friends to try to exercise freely some of the things you learned on an exploration that makes sense for yourself. And so that's what I did. My friend Stefan Slater in 2019 got together and we pitched to my advisor at the time, Yasmin, like an exploration that looked like data mining YouTube. And we argued and later published a paper based on the results we found that YouTube and specifically Minecraft videos on YouTube were wildly popular. And so we said, we wonder how people are learning or teaching each other um, how to do things on the YouTube instructional videos. And so that's what we did. Stefan and I scraped all the YouTube comments and we analyzed them to see how people were teaching each other. And we learned some pretty interesting things. You can find the papers yourself if you're intrigued by that and want to explore them. But later, my friend Syed Ahmad Rahimi, I think you know that Syed Seda. We did a similar project where Syed was exploring ideas and creativity, and I had done this Minecraft work. And so what we did was we scraped YouTube again to explore how people were being creative in the Minecraft environment. Um, and then later, we wrote a journal article to sort of help us understand creativity and notions of like expanding creativity. But after doing these sort of side projects as a uh, more senior grad student and early newbie sort of assistant professor, I started to wonder, why aren't kids doing this? Like, why aren't youth? I was a high school. One of the things I forgot to mention is that I was a high school science teacher, biology specifically, for almost 10 years. So I understood what youth at the high school level could do. And I began to wonder why we weren't teaching computing or data science in these ways. In fact, many of the ways that we look at computational data science today, most of the programs out there are prescribed inquiries where students, teachers, and curriculum developers define what the inquiry is and then superimpose it on the student where they have to sort of replicate a finding, which can be good and bad. But I wondered, I have this vantage point of being able to peek under the hood as a researcher. Why aren't learners able to sort of peek under the epistemic hood to see how people are sort of chatting about learning and then how scholars are sort of creating narratives around that? And so I posed the question, what would it mean for the field and our citizenry if we worked with pre-college groups to empower them to peek under the hood? That is, create inquiry experiences where themselves could drive the question and the process, and even the narratives that result. And so I began to reflect about what was happening in data science as a trend. And we knew, and I realized quickly that data science is a global priority that permeates everyday life. In fact, if you've interacted with or touched any of these sort of technologies, then you have been subject to data science. It's widespread and increasingly interdisciplinary and ubiquitous. Digital platforms, as you're all aware, collect and harness massive troves of data, and data sources are leveraged to shape public knowledge, perception, and decision making. In fact, data science is a global priority for reasons related to innovation. Data science as a field drives a lot of the innovations we see with AI, machine learning, and other adjacent areas. Um, in addition to that, innovation accompanying it requires priorities related to occupational attainment, that is, a workforce suited to be able to participate in the economies that result from data science. And then, probably more broadly, this is a priority for not only our country, but the world because of reasons related to public literacy. That is, how are we supporting our citizenry, as I said earlier, to be able to understand how data science shapes their world and how they make decisions in many cases. And then underlying all of this are issues of equity and how we might sort of make sure that the innovation, the occupational attainment, and literacy reaches folks equitably. I mean, we only have to look to the recent COVID-19 pandemic to realize how important it was for people to be not only attuned, but also keenly aware of what was happening with COVID, and even more so the algorithms driving sort of the ways information was being represented or shared. And so as I'm sort of exploring these ideas and the notion that, why aren't pre-college students doing this? And And we know that data science is a priority for different reasons, and we know that there are pitfalls. I started to wonder before I had the insight that I shared with you earlier about all the programming, what was being done, I wondered. And so I looked and I found that efforts in higher education, post-secondary included, so undergrad and high school, or high school and undergrad, have flourished. There are a lot of programs, and in fact, pre-college groups, there's not as much as college with regard to computational data science, but there are some, and most of those are programs where, as I said earlier, curriculum is developed by others rather than students. There are a few where activities and data sources are personally meaningful, but big data sets for pre-college students are typically curated by others. And this is a problem for a couple of reasons. The more benign problem, the more harmless one, is that when kids are carrying out computational data science, this important field, in their classrooms, they're learning about things that are not really connected to their everyday life. We know how important that is. So the more benign sort of issue with that is it's either not happening in their class or they're connecting with things that are like sort of erroneous or not generalizable to their experience or future experiences. The more problematic view, I think, or more nefarious, if you want, is that in some of these programs, kids are constructing knowledge and ideas around data sets that generate by design narratives that are deficit in orientation. And we know that when a kid is learning science in a way that sort of takes a deficit approach to who they are and their culture or their neighborhood, that can have adverse impacts on their participation in future engagement. Let me just give you an example. I mean, there are programs out there that I've seen represented where kids are learning about their neighborhood test scores in high school performance. And the narrative that gets generated out of that is that your neighborhood is not doing as well as X other neighborhood. And we know it's so much more complicated than that, but that is what is being done or carried out in the classroom. And we know that this can be problematic for reasons, so many reasons. I won't list them here, but I think the result is learners being disengaged or not participating in the field. And why should they? And we know from folks like Jane Margolis, who wrote Stuck in the Shallow End, and Ramon Momaro, both of which sort of share a common thread in thinking about how technology or participation or the lack thereof can have deleterious effects. Jane talks about specifically with this metaphor stuck in the shallow end around computer science education in California, where the large majority of students are Hispanic, but a significant minority in computer science education classes. And she uses this metaphor to harken back to the Jim Crow era in the United States, where pools were segregated, and as a result, people of color could not swim in public schools. And the um, result of that many generations later were statistics that showed that people of color were many more times more likely to drown as a result of not having this generational access. And she pointed to computing as following a similar sort of arc, wherein when kids disengage from the field, they don't participate, and all the fruits that come out of that field through occupation, innovation, etc., are relegated to those who were able to participate. Ramon Amaro goes even further to suggest that tech folks would, as a result of non-participation, not only be sort of not be able to be productive in it, but would, as a result, be subjects of the technology rather than agents who guide and shape it. And so the risks are huge. And so as I was coming to sort of these sort of realizations, it became apparent that we needed a solution or a way to sort of get around this. And I pitched to the NSF that we develop a program where learners could pursue their own inquiry in computational data science, learn computing, learn data science, and do so in a context that was personally, culturally, and sociopolitically meaningful. And we used, as I said earlier, Latson Billings and Geneva Gay and many others, from Chris Emden to Doug Larkin, Nicole Pinker, Jean Ryu, Jay Margolis. I don't have Tia Mackins here, Brian Brown. All of these folks have been talking about culturally responsive compute education, starting in language arts when Latson Billings was studying teachers, but also moving it toward or thinking about this in the context of STEM education and more recently computing education. And so we borrowed from this perspective to design and develop a curriculum called Coding Like a Data Miner. And that's what leads me to sort of the core of what I am delivering today. And so remember, I took you to who I am, what sort of is happening in data science, trends, opportunities, and the tensions that are really related to equity and what we're doing for students and youth, pre-college youth, and contemporary STEM subject areas. And so I'm going to give you a case example of what this looks like, how it turned out after we were funded, and what we learned. And so if you're curious about the project, you can go to this QR code, screenshot it, and then look for it later. You can Google me and Coding Like a Data Miner. You should find it that way. If you want to look at the curricular resources, the slide decks, the video instructional videos, the worksheets, those things can be found online. So one of the presentations I gave early on sort of explored the development of this program, and that yielded several sort of papers that I'll go over in a second. But the way we conceptualize this, as I primed you earlier to the idea, is as a sandbox approach to computational data science. We said cultural relevance is a central design principle that we wanted to stick with. We cared about computational literacy as a learning goal. So the ability, I don't just mean like computational thinking, if you're familiar with the jargon, like abstraction, pattern recognition, these sort of canonical ways of understanding computation. I also meant it from the sort of, and I borrow from Yasmin, Chris, and Deb, Louise, sort of a paper they presented on this subject. But I thought about computational literacy as engaging with the socio-political, so helping people think about not only what is computation and how to enact it, but also thinking critically about it and how to leverage it in ways that might initiate change in the community or for their lives. And when we thought about these as sort of important areas, but we also said in developing the curriculum, we don't want to develop it ourselves. So what we did was use a participatory approach through co-design with youth and adult educators to work together to develop what was eventually Coding Like a Data Miner, the curriculum. Again, you can take this QR code and look at it. And we learned a lot in the process of developing this curriculum. To begin, we wrote a few papers around this design. We looked at everything from what it looks like or the affordances and constraints of co-designing with people in this space. Like, what are the tensions that emerge when youth are positioned as leaders or central to design decisions and what the learning priorities are. We wrote about what it looks like to prototype the curriculum and the features that lend themselves to things like math learning or computing or other areas of learning. And we examined very closely what it looks like to sort of engage in sandbox data science and sort of the affordances and constraints of that approach. And so you can take a look at any of these if you're interested in what we gleaned about the design. Let me take you to what that product was eventually. And so Sandbox Data Science, we characterize as having typical data science phases. Data gathering phase, where someone's scraping the data from a source. Doesn't always have to be big data, but in our context, it was. We looked at process data pre-processing techniques, so cleaning the data up so it's usable for analysis, analyzing the data, then representing it in various visualizations so that one can communicate or glean meaning from it, and then communicating that data. And we broke up the curriculum in phases. We had an introductory phase, guided inquiry phase, scaffolded inquiry phase, and free inquiry phase. And we learned in our co-design sessions that every audience that we would work with would be potentially different. Some with lots of experience in math or computing and data science, others with less. And so we developed in the blue box there a very modular introductory section where a teacher or a learner could come in and say, well, you know what? I know how to do data mining, but I need to brush up on statistics. And so they can go through these modules and just sort of on demand support for different areas that encompass all these phases. And then we said, why don't we have the teacher make a worked example? This came out of our co-design sessions where all the students, kind of like happens in math learning, follow a full set of steps for data mining, where the teacher comes up with a question that he or she knows is relevant to the students, and then walks them through what it looks like to gather the data, process it, analyze it, and so on. And then we said, after that, let's move them into a more scaffolded experience wherein they can tinker or play around with different things, like shift the research question to be something slightly different, or analyze it in a very different way, or just play around with what happened in guided, or in another example. And then eventually we wanted to reach the what we characterized or thought of as the more holy grail type experience, where learners would be able to engage in free inquiry or carry out computational data mining completely on their own terms, using processes that they thought made sense, or more broadly, I like to say, their own epistemic styles, as a sort of nod toward this goal of imparting epistemic agency. And what's really special about this approach, from going from structured to open inquiry, is that when we eventually reach the last sort of free inquiry place, we are couching the learning in an authentic practice. And so this is yet another sort of nod to what it might look like to support learners in ways that give them access to innovation, occupational areas of these fields, and probably more importantly, literacy, having a peek under the hood insight into what it means to carry out and do computational data mining. And in this space, we used the Colab coding environment. It's a Google-based Python platform where kids did all the coding, from load relevant code libraries they needed to setting online keys, which effectively means uh, adding their personal passwords to the code so that they could verify themselves with Twitter, searching keywords, requesting tweets, and then later processing those tweets. And the actual environment looks something like this. So if you go to the QR code in the slides that I shared earlier, you'd see things like this, where they just run in the guided, and actually in all the modules, prescribed code blocks that they execute using the little play buttons here. They can change the hashtags if they want. This is the more guided section. These blocks you can imagine being more blank when they're doing it on their own. We share with them possible variables that they can pull up from the Twitter. Remember, they're scraping all this from Twitter, and if you have questions about that platform and why we chose it, we can talk about that during the Q&A. But this is what they're able to turn up. And as a result of the hashtags and these variables, they generated spreadsheets that can then later be processed on the Colab environment using code. And after we designed all this, we implemented it. We're on our third implementation now. It's happening in Philadelphia, actually, as we speak. We did an online version, and then two in-class summer camp versions. The first one that we did was a 10-day online workshop where youth spent about 4 hours a day 8 youth participated in it from all over the country. In fact, I think we had a youth from Mississippi involved. They range from novice to more experienced in computing. We taught them to scrape Twitter, and then their performance task was a final presentation where they had to show us a inquiry that they pursued that was personally meaningful to them, and the process of going through each of the phases that I laid out earlier. And then we assess learning outcomes, their perspectives, changes, and project topics. What we found was that in this space where not many people are letting kids sort of drive the inquiry themselves, we found that kids actually have lots of ideas and questions that they can use as a starting place for exploring. And so this slide just represents some of them. They asking questions like, what's going on in the war? This being what was happening in Ukraine, not the more recent one that is taking place in Israel and Gaza. Other questions included questions around animal testing, sentiment, popularity of sentiment of programming language. You can imagine a youth who has a lot of code experience asking that question. Another person asks, "Who's the GOAT? What do people think is, or who do people think is the greatest of all times? King James or Michael Jordan?" And so many other questions they asked that they could use to drive their inquiry. And so I'm going to dig into this one, or maybe two projects, depending on how much time we have. The first one is what player is the people's GOAT, Messi or Ronaldo? And so here we had a student who was really curious, or a youth who was really curious about who the public thought is the better or greatest of all time in terms of soccer. And these are the slides from that youth's project. So he presented his project title, he provided a rationale for why this kind of work is needed and why it's hard to figure out who the GOAT is and how he's going to use computational data science. And when he did this, he sort of presented some background around who these players are and why this is important. He writes, the GOAT debate between two being a harshly fought battle from the opposing sides of fans using stats goals and assist titles. These are all indexes that people use for ascertaining who the GOAT is. And so he said, I want to throw away the stats, these sort of decontextualized measures, and instead I want to look at what the public actually thinks, their opinions. And so he walked us through the process of data gathering, the code he used. As you can imagine, having a learner sort of lay out all the code and explain what that code is for helps us understand what learning took place in the process. And so he walked us through how he pre-processed the data, what he did to organize it in a way that made a lot of sense, what search terms he used to gather data that was relevant, and how he began to represent that data. So he showed us how he, after generating the spreadsheets he wanted, he moved to, instead of staying in the Python environment, the Colab environment, he moved to Excel, and then he generated charts to help us understand what was happening. He used word clouds from the Python environment to understand what people were saying in the nature of their tweets. And then he came to this in conclusion. It appears that Ronaldo won the debate. So going back to this, he said Ronaldo and his tweet count had more favorable engagement in the tweets. And even in the word cloud, he said that Ronaldo, people were talking about him a lot more. So by all accounts, Ronaldo is the winner. But then he poses this as a question. It appears he's the winner, right? And then he says, think again. With further analysis of the data, most of the tweets that we're looking at are actually trashing Ronaldo. And so his peek under the hood, or ability to sort of explore, helped him understand that the typical indexes or variables that you might use to really understand who's the winner is not enough. You have to dig into a little bit more context. So because I'm running short on time, I'm not going to go through the next project. But generally speaking, I'll share that the student wanted to explore public sentiment about animal testing. And the reason I like this project and to share with y'all is because she goes through a lot of code and code complexity to really organize and process the data. She concatenates or joins multiple Excel spreadsheets in ways that allow her to collect the most robust or the broadest swath of data. She processes that data, lots of computational sort of high ceilings, if you want, fluency from this learner. And she eventually reaches the conclusion that people are thinking about animal testing in very nuanced ways. And so to sort of conclude the talk here, I just want to highlight some reflecting points on principles for open inquiry or principles for culturally responsive computational data science or sandbox data science, as I've described it. If you want to read any of the papers that came out of this work, you can go to my Google Scholar. We sort by year. A lot of my most recent work came out of this 3-year project. And here are the reflection points. And so the first is that when you're designing for epistemic agency, that is learners being free in the inquiry process to do whatever they want rather than something totally prescribed for them, there's a tension in designing for relevance in inquiry and science that science fields that intersect. This tension is really like figuring out not only what the educational priority is it math, is it computing, is it something else, but also figuring out how you might make this meaningful for the learner, right? And so that tension is one, I would argue, is related to power and who controls the learning priority and who sort of does not. And so addressing that tension head on, I think, is a step toward really being authentic and and honest about the way you are supporting learners in their epistemic freedom, if you want. These tensions are also epistemic in nature. And what I mean here is who gets to decide what is the appropriate data source? Thinking back about the project that I shared with you all, who gets to decide what's the right analysis? Who gets to decide what narrative is represented as a result? All of these are epistemic practice or epistemic in nature, and it's really important to sort of not only think about the learning priorities and who gets to decide them, which I think I said are connected to power, but also who gets how that power sort of shows up in the various practices that learners engage with. And then this tension, I said, exists at all stages of learning design. So when you're designing a curriculum, teaching with a curriculum, this tension around who gets to decide and not, and the extent to which the teacher is designing and undermining learners and their freedom to conduct inquiry can be problematic if not addressed head on. Everything from question formation, as I said earlier, to the methods and analysis. And in order to overcome these, we have to look to all the players, the people who come up with the theories and the conceptualizations around these areas, defining what counts and what doesn't, the methodological, that is, the folks doing the research or designing how we might assess, and then the pedagogical, how we might teach these areas in ways that are really productive. And so I hope that these reflecting points are starting points for you as you think about your own work and what you're doing for learners, but also reflective in the ways that that attend to how those goals might be undermined by decisions you make. If you're interested in the field data science, I'm collaborating on a conference that's out. It's funded initially, at least, by the Valhalla Foundation and the Bill and Melinda Gates Foundation. And submissions are already closed. And so if you just want to participate to learn more about what people are doing in this nascent field, please Google us or check it out. Proposals are already sort of past due. And I'd like to acknowledge all the folks. There are a little team of folks who were involved with this project, from former doc students who are now faculty at Penn State, as an example of Reza, to doc students, to undergrads, to others. Thank you all for the time, and I'm glad to sort of open this up with the remaining time to questions.
I'm still formulating my question, but I really enjoyed your talk. I don't know if you probably didn't. I dropped in a link that might be of interest to you, Dr. Walker. There's a big AI initiative going on in Mississippi right now.
Oh, cool.
And so I'm just thinking about it in relation to some of the things that you've been sharing. But I'm still thinking about my question, but thank you for joining us.
Oh, I love that. Mississippi's AI network, bridging education and workforce. Yeah. Thank you for sharing that. I'll take a look.
Yeah, we have about 10 minutes. If you have questions, please, feel free to unmute yourself and ask directly, or you can leave them in the chat box. So I will be monitoring them. So just a little note, Dr. Walker, the link about the curriculum didn't work for me when I tried to scan. Is it possible if you drop the link in the chat box?
Yeah, if you go to abclearninglab.com, you should be able to find it there. Under projects and collaborations, there should be coding like a data miner. Let me just make sure. Yeah. Sometimes, as you all know, when we use the sort of QR code generator, it expires. So maybe that expired from back when we made it.
Thank you
Thanks for bringing that up. And you might hear my dog in the background. She's dreaming right now, so she's kind of like grunting.
That's cute.
And so if you don't have questions about the project, I would also love to know who you are and what you're working on. Um, and as you tell me that, I can think about how they sort of connect to what you're doing. Peeking under the hood, phrase peeking under the hood. This is an excellent question. So for me, peeking under the hood means not taking what someone has presented to you for what it is, being able to look at the inner workings of how that was produced. So I think I used like the tweet from our former president back when, if you remember, like 4 years ago when we were in the grips and thick of it when it came to COVID, a lot of us were just unsure about information that was coming out. Example being around what protocols to use to keep yourself safe. And as you can imagine, in a world where things are looking apocalyptic, information is like key. And so I'm saying here is a moment where you can either take what your leaders or people that you sort of lean on are saying, or you can look a little bit more deeply and critically around the information surrounding that. It's really a public literacy argument, a science literacy argument. And so peeking under the hood in my context, computational data science means teach kids how to ascertain what people are saying or thinking about, or what the data is saying about something, rather than have them sort of consume it on their own. I hope that makes sense.
We have one question in the chat. Taylor asks, is it possible to use the process of data mining to gather data from multiple sites at the same time?
So when you say at the same time, I think the answer is no. Like, because when you're communicating with a database, there's a specific way to communicate with the database. But if you say, I want to gather data from, I'm going to just name the publicly accessible data sets. I want to gather data from YouTube. I want to gather data from a government organization like USDA.gov. and I want to gather data from Twitter to triangulate maybe? The answer is yes, you can totally do that. Like the way you would carry it out though, technically, is through three separate inquiries. And like one of the students' projects I was running through, you'd have to join those data sets together, which is technically not complicated. Um, but that's an excellent question. You can draw from multiple data sources, but at the same time, I would want to nuance what you mean by that a little bit more.
Dr. Volker, we have a question from Sandra who couldn't be here, but they posed some of the questions prior to your talk.
Sure.
So she was interested. I'm just reading her question. She says, your research is vital to the ongoing discussion about updating, revising, or restructuring our K-12 public school curriculum to align with the current innovation revolution. The next generation science standards were a significant step forward, but only 20 states have fully adopted them, while others have only partially implemented them. So she's asking, how do you think your research into gaming, coding, biotech, and other 21st century science skills can be integrated into schools as core components rather than occasional electives or informal education opportunities?
Yeah. So one of the practices I think we don't do enough in the practitioner side, and I don't mean just the teachers, I also mean like school leaders and the people who sort of create these things, these standards, if you want, is we don't reflect enough or modify enough to account for developments. We sort of build a framework and then we say this framework will work for years to come, and we're not used to assessing affordances and constraints. If we do this, we get these very great outcomes. But then here's the blind spots that emerge as a result. And so I think number one is maybe making that process of assessing affordance and constraint normal. And that's hard, I think, for some school leaders to do, to acknowledge that there are shortcomings and we can live with that necessarily, or constraints, I'll put it. But then the other piece, and I found this useful in being able to communicate with people who want to try this, is that you match it up to what the priorities are for those teachers, right? Like you show teachers, look, you live in a context like Texas that has a set of essential knowledge. And here is where it matches up. In our co-design sessions, that's what we did. We got the college board curriculum standards. They're not really curriculum standards, but we use their framework, and we use the Texas essential knowledge. It's called TEACS. It's basically Common Core. And we made spreadsheets where we said, here's a practice in computational data science. What standards does it reach? So that we had the evidence to teachers, and we could say, look, if you do this, you check off all the boxes. And so it's those two things, right? It's one, leaning into a culture of recognizing that things change and there's affordance and constraints. That's a very critical stance to take. That doesn't happen a lot, I think. Critical, I don't mean like bashing it. I just mean like reflective and acknowledging pros and cons. And then the second piece is speaking the language of the teachers and the educators that you want to reach. And that starts with demonstrating how your program aligns with or doesn't with their priorities.
Thank you. Dr. Wallace had another question. Do you want to ask?
I know we're tight on time, but I feel like, I don't know if what you just said makes me think about this question too, about normalizing affordances and constraint. But my question is kind of, in your research, you've been talking about smaller group kind of interactions that happen. And I'm wondering and thinking about epistemic freedom, like what should we be considering? What are the affordances and constraints when you start mapping that to population level, like state level activities and goals?
Well, I think the clear affordance is that you get learner, for me at least, you get learners not only experience carrying out these kind of processes, which work for jobs and things like that, but you also give them experience with understanding like how the sort of epistemic liberties people take when analyzing that data. And that's a step toward being critical, right? Like being able to say, well, I have this population-based data. This is what's missing. And for me, accompanying this is this notion we spend a lot of time in the sort of academia thinking about, and that is triangulation, right? Like, how do you look at population-based data, but then also understand how the narratives that sort of undergird it, and how might you use other data to sort of support or um, create tension around what you're seeing. I think the best example I have is what I hearkened to at the start of the talk with kids using population-based data about their performance on school districts. And it's so problematic to have a learner sort of constructing identity or a sense of self around a narrative that is problematic. But it could be powerful to do if the teacher is helping them understand, again, the liberties and the subjectivity underlying this, and then maybe going further to understand in community, maybe from an asset frame, what might be driving these issues around poverty, around political acts like redlining, as an example. That can be a really liberating and powerful space within which to understand how society is constructed, how inequity is constructed, and then how one might leverage computational data science as a tool to either reenact or reify them or dismantle them. I mean, I'm talking on a soapbox to people who probably share the same viewpoint, but um, I think that is a start. It's a great question.
Thank you so much. Just to be mindful of the time, I wanna thank your audience for their great participation, and thank you, Dr. Walker, for that wonderful, engaging, interdisciplinary work that you shared with us today.